value being sent over to, there we go. So it looks like we're signed into Twitch, and let's go over here to my channel over here on YouTube. It's still sending data for YouTube, and then it looks like it will be up and running. So let's go ahead and give it a little moment. There we go. So now it says it's streaming over on YouTube, scheduled, and we go ahead and start it, and we are there, ready to go. So hello everybody. Today is August 14th, 2026. It is currently 10:04 in the morning. August 14th, 2026, 10:04 in the morning. It is a Friday. It's a Friday. So what's the purpose of the stream? As the title card indicates, we are engaged in the process of a review of arithmetic, but not just any arithmetic. We are reviewing using an old textbook from the 1830s by Augustus De Morgan. Augustus De Morgan, a foundational figure in the history of mathematics, especially in the 19th century. And so we have, as you see, our clock is running. We have almost 3 hours is what we started with on the clock. And how this works is I have my paragraph set up, my little PDF reader off to one side. And what I do is I do a strict copy of the text, but I am doing copy work not in orthographic script. I am doing the copy work using Gregg Shorthand, Gregg Anniversary Shorthand to be precise. If you are interested in picking up a copy of the book for yourself, there is a link down in the description to the PDF version on Google Books. Of course, you can also grab a copy for yourself from Internet Archive, Hathi Trust. There are quite a few different locations where you can access the book. And once again, this is the Elements of Arithmetic by Augustus De Morgan. Excellent textbook, as we're finding out that he does a wonderful job of prepping the students not only for rigorous thinking about numbers in general, but also in preparation for algebra, trigonometry, later on calculus, and so on and so forth. It's just an excellent primer and a wonderful way to review arithmetic. So, with that being said, we are currently on paragraph 45. All paragraphs are numbered in this book. One of the nice things about older textbooks is the way that they structure their information, and in fact, most older texts had some sort of numbering in the paragraphs, so it allows you to easily reference and scan the book based on the numbering system. Okay, so with that, let's go ahead and get started. Like I said, descriptions are down below. If you're interested in supporting me or want to throw a couple of coins my way, I've got my Ko-fi and Patreon pages down below. So feel free to take a look at that in case you're interested in that. And let's go ahead and go. So here we go. Close this page over here, and we begin. So I'm on number 45, paragraph 45, and what you'll see is just some basic signs for the Gregg Shorthand. So this one is a paragraph marker, okay? And we now throw in 45. Okay, 45. Let's go ahead and highlight this, highlight the paragraph right there, so we're ready to go. And we start copying. If there should not be as many figures in the lower line, if there should not be as many, and many is an M in stroke that then goes all the way down, so there's many, as many figures in the lower line, figures in the lower line as in the upper, and move down here. Oh, we're at the bottom of the page. Let's go ahead and throw another one down below. Elements of Arithmetic. Section 2, page number 11. Let's go ahead. Section 2, page 11. Elements of Arithmetic, Section 2, page 11. Go back over here. We're in place. Let's go. Not be as many. If there should not be as many figures in the lower line as in the upper, and this is upper, as in the upper one, proceed as if there were, as if there were as many ciphers as at the beginning, and cipher is cipher, as many ciphers at the beginning of the lower line as will make the number of figures equal, as will make the number of figures equal. Okay? Period. You do not alter a number. I'm going to put my phone on Do Not Disturb. There we go. You do not alter a number by placing ciphers at the beginning of it. You do not alter a number by placing ciphers at the beginning, of it. For example, comma, 00810 00810 is the same number as 818 is the same number as 818, comma, for it means that, and for this we'll just use a paragraph marker, that there are zero 10,000s, 0,000s, 800s, 1 10 and 8 units. Okay? And 8 units. And that is the meaning of if you have those zeros placed in there, it simply means that you do not end up with any values in the hundreds, in the what did it say, in the 10,000s and the thousands position, or your only value starts in the hundreds position. Okay, zooming on down to the next page. Here we go. Come on. It doesn't want to go exactly the way I want it. There we go. There we go. All right. The first two signs are nothing, and the rest is. The first two signs are nothing, comma, and the rest is, and the rest is then written as 800s, 110, and 8 units, and 8 units, or 810, 818, 818. There we go. Moving on, next paragraph. The second does not differ from the first. The second does not, and then differ is, I think that's probably differ if we flip it around like that. Let's go check. Oh, it's just the same as difference. Very nice. So we'll go ahead and erase that, and we'll put differ here. Does not differ from the first, comma, except in its being said. Except, and let's see if that is except. Nope, it's sep. Except in its being said that there are no thousands, that there are no thousands, and no tens of thousands in the number, comma, which may be known without their being mentioned at all. Without their being mentioned at all. And at all, let's see if that is a phrase. It is. Good, good. You may ask, comma, you may ask, perhaps, and perhaps is going to, isn't it just perhaps? P-R-A, and is it P-R-A-P? it does need the second P. You may ask, perhaps, why this does not apply to a cipher, why this does not apply to a cipher placed in the middle of a number. Check middle. Yeah, needs the D. Placed in the middle of a number comma, or at the right of it, or at the right of it, comma, as, comma, for example, in 28,007. And 39,700. Question. But you must recollect. But you must recollect comma, that if it were not for the first two ciphers, that if it were not for the first two ciphers in the first, comma, the 8 would be taken for 8 tens. The 8 would be taken for 8 tens, comma, instead of 8 thousands. Semicolon. And if it were not for the ciphers in the second, and if it were not for the ciphers in the second, comma, the 7 would be taken for 7 units. The 7 would be taken for 7 units, comma, instead of 700s. Period. And that is the rest of 45. So now let's go ahead and read back over what we have there. Zoom back up to the previous line. We're looking for 40, 45. There it is. And we start. Okay. If there should not be as many figures in the lower line as in the upper one, proceed as if there were as many ciphers in the beginning of the lower line as will make the number of figures, let's make that G just a little bit more pronounced. There we go. Number of figures equal. Ooh, is that let me check equal quickly. Yes, good. Equal. You do not alter. Yeah, you do not alter a number by placing ciphers at the beginning of it. For example, 00810 is the same number as 818, so 818 would be the same in both instances, for it means 0, 10,000s, 0,000s, 800s, don't forget our aspirate, 800s, 110, and 8 units. The first two signs are nothing, and the rest is 800s, 800s, 110, and 8 units, or 818. The second does not differ from the first. Does not differ from the first without. Is that without? Well, except. So let's go ahead and make that just a little bit easier to understand. Except. There we go. Except in its being said as there are no thousands and no tens of thousands in the number, which may be known. Let's straighten that up a little bit. There we go. Which may be known without there being mentioned, without there being mentioned at all. You may ask, perhaps, why this does not apply to a cipher placed in the middle of a number, or at the right, hold on. Or, oh yes, at the right of it, as, for example, in 28,007 and 39,700. But you must recollect that if it were in, make this just a little smaller, if it were not for the first two ciphers, and remember a cipher is 0, if it were not for the first two ciphers in the first, the 8 would be taken for 8 tens instead of 8 thousands, and 8 thousands. Oh yes, 8 tens instead of 8 thousands, and if it were not for the ciphers in the second, the 7 would be taken for 7 units instead of 7 hundreds. There we go. Grab a little sip of water. Okay, so continuing on. Now we have an example. Whoa. Well, there's a number for you. Wow. Wait. Do I need to show all the examples? Oh my goodness. No. I'm torn. No, I'm gonna skip the examples. I'm gonna skip the examples for right now. Um, I mean, they're all math examples, which it would be better for me to to lay those out using non-Gregg and to be able to write in normal layout. So I'm gonna skip all those, and we're just gonna continue on with the lesson. In the following table, subtract b from a from the remainder, and so on until b can no longer be subtracted. Find out how many times b can be subtracted from a, and what is the last remainder. So yeah, those are all examples that I can do as separate videos, because for right now, it is just the review and just the Gregg shorthand that I am interested in. But if you are interested in taking the time to work through those examples, the PDF is below in the description, so have at it. Be my guest. Let's go ahead and call it there. So that was 11 pages of copywork, and that's all of section 2, by the way, so woohoo. Now we can move on to section 3. So let me go ahead and save section 2, and I'm going to go ahead and export it as a PDF. Export as a PDF. Save it in mathematics. There we go. Fundamentals, and this one's going to be section 2. So let's go label it as 002, section 2, and this one was addition and subtraction, right? Addition, subtraction. There we go. It's a PDF file. It is being saved and exported. And now I will be able to open up another document. In fact, I'll probably just save this PDF. I will save this PDF and delete all the pages except the first one and restart the whole process. So let's go ahead and Control Alt S, save this as section number 2, or section number 3, pardon me. So we have 003 arithmetic, section 3. We're going to save this. All right. And it's been saved as the new section. Now we're going to delete the pages. So we delete the page, Control Shift Delete. Control Shift. We just keep on deleting until we get to only 3 pages or 1 page left, and then we can select everything inside the page and clear the document, resize the page, and now this one gets elements of, here we go, new, nope, we don't need new, we just need to go ahead and start. So we have elements of arithmetic, section 3, give ourselves just a little bit more room, section 3, and this is going to be page number 1. All right, now we zoom on over and we start all over again. So section number 3, and that is section 3, new line, and we have multiplication. So this is mul, and then I think it goes under, right? Multiplication. Let's go ahead and check that. It is a PLE, not PLA. Okay. Multiplication. New line. This is paragraph number 47, and this is where we highlight because that's the important one that we need to get to. So we have paragraph 47, and we start. I have said that all questions in arithmetic, I have said that all questions in arithmetic require nothing but addition and subtraction. I do not mean by this, I do not mean by this that no rule should ever be used except those given in the last section, except those given in the last section, comma, but that all other rules, but that all other rules only show shorter ways, only show shorter ways of finding what might be found, of finding what might be found. Period. If we pleased by the rules there deduced, if we pleased by the rules there deduced, by the rules there deduced. Period. Even the last two rules themselves, even the last two rules themselves are only short and convenient ways, are only short and convenient ways fix that S, shape it up a little bit. There we go. Of doing what may be done, of doing what may be done with a number of pebbles or counters, with a number of pebbles or counters. Period. Yeah. And that is the end of 47, so that means we go back up through and we reread that paragraph. Okay, here we go. I have said that all questions in arithmetic require nothing but addition and subtraction. I do not mean by this that no rule should ever be used except those given in the last section, but that all other rules only show shorter ways of finding what might be found if we placed before, if we placed, or if we if we pleased, if we pleased by the rules they're deduced, and that was speaking of in the last section, they're deduced. Even the last two, and two, I'm going to change that to the Arabic letter. The last two rules themselves are only short and convenient ways of doing what might be done with a number of pebbles or counters. Next paragraph. Paragraph marker. Highlight. Start. 48. I want to know the sum of 5 17ths. I want to know the sum of 5 17ths. For this, I'll use the Latin letter. 5 17ths, comma, or I ask the following question, or I ask the following question, or I ask the following question, semicolon. There are 5 heaps of pebbles. There are 5 heaps. And let me check heap. I doubt heap is in the dictionary, but we'll check it anyway. There's cheap, but there's no heap. So let's go ahead and add that. Simple word, but still worthwhile. Okay. There are 5 heaps of pebbles. Comma, and 17 pebbles in each heap, and 17 pebbles in each heap. Semicolon. How many are there in all? How many are there in all? Question. Write 5 17ths in a column. Write 5 17ths in a column. And make the addition, which gives 85. Let's go ahead and add the page below. Elements of Arithmetic, section 3. Page number 2. Okay. There are 5 heaps of pebbles and 17 pebbles in each heap. How many are there in all? Write 5 17s in a column and make the addition and make the addition, comma, which is 85. Which is 85. Period. In this case, 85 is called the product of 5 and 17. In this case, 85 is called the product. It's called the product of 5 and 17. Let's go ahead and make that a little bit clearer. Five and 17, comma, and the process of finding the product. And the process of finding the product is called multiplication. Is called multiplication. And that's going to use double sign to show that it's kind of a specialized form. It's the small capitals, comma, which gives nothing more than the addition, which gives nothing more than the addition of a number of the same quantities, and quantity was quantities, I believe. Yep. Number of the same quantities. Here, 17 is called the multiplicand and 5 is called the multiplier. Here, 17 is called the multiplicand. We'll see if that's in the dictionary. Multiplicand, maybe. Let's go check and see if that is the case. It is there. So all we do is we just put the nd, we attach it to the remainder of the stroke. Okay? So multiplicand. The multiplicand, and that's underlined, comma, and 5 is called the multiplier. And 5 is called the, and then multiplier is let's check plier. Yep, so we just add the diphthong and then the R. Multiplier, period, and add that, add the lines below to show that it's hyphenated, and then we start reading back over 85. I take that, yep, 85. 40, okay, that was 448. There we go. We start 48. I want to know the sum of 5 17s, or I ask the following question. There are 5 heaps of pebbles. There are 5 heaps of pebbles and 17 pebbles in each heap. In each heap. How many are there in all? Write 5 17s in a column and make the addition, which is 85. In this case, 85 is called the product, and that needs to be underlined, is called the product of 5 and 17. And the process of finding let's clean up finding just a little bit, make it a little bit more curved. There we go. And the process of finding the product, is called multiplication, which gives nothing more than the addition of a number of the same quantities. Here, 17 is called the multiplicand, and 5 is called the multiplier. Okay? And that was the end of 48. Now we go on to 49. Drop a hyphen. There we go. If no question harder than this were ever proposed, if no question other than this were proposed, and proposed is P-R-O-P-P-O, I believe, and then a line underneath, so let's check that. Yep, that's proposed. Just need to get rid of the O. If no question harder than this were ever proposed, so we need to have the ever. Wherever proposed, comma, there would be no occasion. There would be no occasion, and that's cache, I think. Let's go check that. No, it has to have the ash ending, so, and no O in the beginning, so just cation. Would have no occasion for a shorter way than the one here followed. For a shorter way than the one here followed. One here followed. But if there were 1,367 heaps of pebbles, comma, and 429 in each heap, and 429 in each heap, comma. The whole number is then the whole number is then 1,367, 1,367 times 429, 429, comma, or 429 multiplied and let's see, that's multiply. No, multiply is just mu PL, right? Yes, and so it would be a disjoint D. So, or 429 multiplied by 1,367, 1,367, period. I should have to write 429. I could actually do that here. I should have to, we'll do this separate. I should have to write 429, 1,367 times, 1,367 times, and then to make an addition of enormous length. And then to make an addition of, and then enormous, enormous, let's see if that's anywhere close. Nope, well, if I could spell correctly. There's enormous, it's enom, of enormous length, and length is len, right? Check that. Yes, length, and it does curve down slightly. Like that, of enormous length. To avoid this, a shorter rule is necessary. And then avoid is just void, I believe. No, oh, it's not. That'd be vow, or vowel. So we need void. To avoid this, comma, shorter rule is necessary. A shorter rule is necessary, comma, which I now proceed to explain. Which I now, and then proceed, I believe is this. To explain. And then explain is EXPL, I believe. Yes, good. Period. And that one was all of 49. So now let's go ahead and read back over 49. There we go. 49. If no question other than this were ever proposed, there would be no, is that if there were no question? If no question harder. Oh, okay. If no question harder than this. Yeah, let's go ahead and fix that. Here we go. Ooh, put this back over this way. Good. So if no question harder, and harder would be that one. Harder than this were ever proposed. Yeah, there we go. If no question harder than this were ever proposed, there would be no, there would be no occasion for a shorter way than the one here followed. But if there were 1,367 heaps of pebbles and 429 in each heap, the whole number is what? Is then. Oh, it is then, so that should be just a little smaller for the TH. Is then. There we go. Is then 1,367 times 429, or 429 multiplied by 1,367. I should have to write 429 1,367 times, and then to make an addition of enormous length to what? Of enormous length to avoid this. Yeah, to avoid this, a shorter rule is necessary, which I now proceed to explain. Moving on. A student must first make himself acquainted with the products of all numbers as far as 10 times 10. So here this is an example of your table of memory, right? Or your times table. So we had our addition table, and now we have our times table. So here, let's drop a paragraph marker and highlight it. And then we grab, this is number 50. Okay. The student must first make himself acquainted with the products of all numbers. Put this over here. The student must first make himself acquainted. Acquainted is let me check acquainted. Oh yes, AKA. Must make himself acquainted with the products, with the products of all numbers as far as, and I think that's as far as, right? As far as. Let's go check that. I'm curious if that's in the dictionary. Yes. As far as 10 times 10. By means of the following table. By means of the following table, comma, which must be committed to memory. which must be committed to memory. And that's committed to memory. Okay, and for this, let's go ahead and drop. I'm gonna make the PDF full size. And what I'm then gonna do is, yeah, it's now taking up the full screen. So what I'm gonna do, it doesn't change the view for me, but I'm gonna make sure the volume is turned down so that it doesn't blast your ears. I'm going to grab, screen capture, and I'm going to screen capture the image here. There we go. So I've grabbed the image, and now I'm going to go over to, I'm going to make this smaller again. Oh, don't want to minimize it. I just need to make it smaller, put it back where it was, and there we go. I think we're good now, right? Let's go ahead and check. Yep, levels are good there now. So what I'm going to do is I'm going to go over to GIMP, and I'm going to open up. See here if I minimize this. Yeah, it just makes it small. So what I'm going to do is I need to open up GIMP, and I need to open up Inkscape, and same thing. So what I'm going to do is I'm going to change my view over on OBS so that you can see these. We have GIMP being pulled up right now. This is going to open an existing image. We're going to go screen capture access. Here is our page. So now we should have all of our elements ready to go in order for you to see the image. So let's go over to Gregg. Gregg is already pulled up. GIMP, let me open the selection, grab a source. Here is our source. Hit OK. And then Inkscape, same thing. We're going to go ahead and open the selector. Application window. We do Inkscape. Hit OK. All right. So we should be all ready to go. Let me go back over to GIMP. And once I'm in here, I need to convert the whole image to I'm going to convert it to a black and white. So we go to color, we go to mode, and then we go to indexed. Once we're in indexed, we use black and white palette. There we go. Now the whole thing is black and white. I don't quite like how that turned out. So what I'm going to do is, before I do that, I'm going to go to colors, and I'm going to go to brightness and contrast, and I'm going to really bump up the contrast all the way, and the brightness, I'm going to drop it pretty far down. There we go. Okay, so that already creates a nice strong difference between the two colors. And once I have this image, I then go, now that I have the contrast bumped up and the brightness dropped, it preps it well for then doing the black and white images. So we're going to convert to black and white. That is passable. All numbers are legible, with the exception of maybe 108. Now, one of the nice things is, since I already have my pen pulled up, I can go ahead and fill in some of these values here. I've actually done this quite often for some projects. Let's go to 1, and we're simply going to add our value here and add our value here. This is really useful if you need tables from old books or things like that. You can easily modify the image yourself. I actually did that for a lot of the Gregg shorthand forms, where I had to modify. The forms because there were parts that were missing, and so you just zoom in and you can just clean it up, right? It's a little like a historical restoration. So once you have those values filled in, just looking, doing a quick scan, all of the rest of them look pretty good. We could, if we wanted, this is actually pretty simple. I can do pen, drop this here, boom, 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 boom. And that's looking pretty good. So now what I'm going to do is I'm going to select only the black portion. Okay, the black pixels. I'm going to cut the image and I'm going to paste as a separate layer. And then I'm going to delete the selected layer. So now I'm left with just the black background. And what I'm going to do issues, which is a bummer. Are we reconnecting? Let's see if yep, we did reconnect, so that's nice. I'm going to go ahead and go to the image and I want to scale the image. Let's scale it up to 900 for width and height. Change the interpolation to none and we scale the image. Okay, now it's nice and large. We can go ahead and export, and I'm going to go to pictures and vector assets. This is multiplication table. .png export. Now, so the image here has been saved, and I can then use it wherever I would need. One thing I do want to do though is I want to flip the image. So I'm going to make a copy of the I'm going to make a copy of the layer. Oh, undo. Control C, Control V, and I'm going to hide this one, the top screenshot value. I'm going to go back in over to image, and I want to transform, and I want to flip, what is it? Flip horizontally, right? Yes. So I've got my horizontal flipping, because remember that I'm displaying this as a reversed image or mirrored for you guys. So now that I have the mirrored format, I can export, and then I can go ahead and close down the image because I don't need to save these. So let me close down GIMP, discard changes, and now I can, I don't need Inkscape. I'm just going to do this all in PNGs. So I have that pulled up. Let's go back over to mathematics, and I'm going to pull up Zernal. Okay. And in my next selection, I'm going to zoom out, figure out where to put this. Right over in this column. Okay, zoom over here. Bada boom, bada bang. Okay, once I'm zoomed into this level, I'm going to add a picture. And I need to add multiplication table mirrored. Okay, there we go. There's the multiplication table mirrored. Go ahead and make it full size so that it fits the whole image. All right, and oh, cancel. So now you guys should be able to see that. Yep, comes up pretty well. So there's our multiplication table. And that's the table that you would want to commit to memory. So it's 1 times 1 all the way to 12 times 12. Okay? Really good, important table to have memorized so you can just rattle off the values off the top of your head. Okay? So yeah, that's the table right there, and so now I don't have to write it out, which is very nice. Although writing it to memories or writing it is not too bad of an idea. Let's go ahead and then now continue our copy work. So if from this table, start down here, zoom in just a little more. If from this table you wish to know what is 7 times 7, if from this table you wish, oh, what is wish? Let me check wish. Oh, it's just whoosh. You wish. So you wish would then be you wish to know what is 7 times 7, to know what is 7 times 6. See, even back then, look at this. The book published in 1830, and he was making a 6 times 7 joke. What is 7 times 6? Look in the first upright column. Look in the first upright column. Connect. Did it come back on? It did. Okay. It's interesting. Yesterday, I don't think I had any problems. Yesterday, I had no problems whatsoever with connectivity, and now, boom. I don't quite understand. Maybe using the image editing software causes it to kind of go funny, but I don't know. Anyway, we'll just keep on plugging away. Let me go ahead and grab my PDF, but I also want to have a little sip of water. I feel a little parched. Okay, so we look in the upright column on the left for either of them. On the left, so let's go ahead and zoom down the page. Here we go. On the left for either of them, semicolon, 6, 4, for example, period. Proceed to the right. Proceed to the right until you come into the column marked 7 at the top. Marked 7 at the top. Period. You there find 42. You there find 42. You there find 42, comma, which is the product of 6 and 7, which is the product of 6 and 7, period. Let's see, was that all? That's all of 50. Yeah, so let's go ahead and read back over paragraph 50, but first of all, let's go take a look at this table. I mean, this is just review. Like I said, for most of you, you already know how to navigate a table, a multiplication table. They're really fun. So we have 7s, right? We have 7s here, and we have 6s here. So he said that, what was his point about, where do we look first? Do we go to the column? Look in the first upright column on the left. Yeah, so if we look at the first upright column, we have 6 here. And then what we do is we simply take a look. We isolate ourselves to this particular column, and then we jump down here to the 7, and where the 2 intersect is the multiplication. It is the product which is 42. Okay, pretty neat, pretty neat. So there is our multiplication table, and we continue down, or let's actually read through. So let's go back to the beginning of paragraph 50, and we start. So paragraph 50, we have the student must first make himself acquainted with the products of all numbers, as far as 10 times 10, but by means of the following table, which must be committed to memory. must be committed to memory, and that is here. So as we said, this is the table here. This is our multiplication table, okay? Multiplication table. If from this table of such, right? You wish, from this table, you wish to know what is 7 times 6, look in the first upright column. Let me check upright. Yep, that's upright. Look in the first upright column on the left for either of them. 6, for example. Proceed to the right until you come into the column, what is that? Marked? Yes, that's marked. Marked 7 at the top. At the top. You there find 42, which is the product of 6 and 7. There we go. All right. Moving on to 51. Hold on, let's see here. As it is usual, okay, so he has a little note here at the base. Wow, that's interesting. As it is usual to learn the product of numbers up to 12 times 12, I have extended the table thus far. In my opinion, all pupils who show a tolerable capacity should slowly commit the products to memory as far as 20 times 20 in the course of their progress through this work. Wow, that's impressive. That is very impressive. Should slowly commit the products to memory as far as 20 times 20 in the course of their progress through this work. That is something, De Morgan. Okay. So you should have the products in your memory up to 20 times 20. Wow. That's, okay. All right. All right. I would have to say I don't have them committed to memory up through 20 times 20. Okay, all right. I mean, challenge accepted. Challenge accepted. Wow. Okay. There are ways that you can do that, as it is usual. So where did he put that note about the table? Oh, the following table, by means of the following table. Boy, I don't know what to make of that. Okay. Well, De Morgan, I guess I've got work to do, huh? I gotta memorize up through 20 times 20. Yeah, might as well. So here I am. I've already learned shorthand and I'm using shorthand and I'm complaining about memorizing 20 times 20. That's funny. That is ironically funny. Okay, so let's go on to 51. I'm not going to worry about writing that little note about the memory, although, like I said, that's a pretty good point. That is a pretty good point that he's making. And it's not bad. I mean, to memorize things, it only does you good. So, anyway, continuing, you may find in this way. You may find in this way, comma, either 6 times 7 or 7 times 6, comma, and for both you find 42. And for both you find 42. That is 6 sevens. So we have, that is, comma, 6 sevens, 6, there we go, sevens, is the same number, is the same number. Oh, we need to add another page below this. There we go. Page number 3, Elements of Arithmetic. Elements of Arithmetic. Section 3, page number 3. Okay. 6 sevens is the same number as 7 sixes. As 7 sixes. This may be shown as follows. This may be shown as follows. Is that follows? Does it have the S go down? I think it does. As follows. If we check that. Yep, the S curves down. This may be shown as follows. Place 7 counters in a line and repeat that line in all 6 times. So we're going to go place 7 counters in a line in a line, comma, and repeat that line in all 6 times. And repeat that line. Let me check repeat. Yepers. And repeat that line in all 6 times. In all 6 times, period. The number of counters in the whole is 6 times. So before I do that, let me go ahead and do that here. So what I'm going to do is, let's do a counter, and I'm going to grab a fun image to use for that. So let's go, we're just going to do 6 of them. So I know what, let us do the dove. Oh, there we go. Nice. So let's do 6 doves. All right. Oh, there we go. Zoom out here, and we're going to do 6 of these. So we're going to do 6 doves in a row. Let's go ahead and grab this guy, make him a little smaller. Boom. All right. And make it just a little bigger. I know it looks kind of funny with it being reversed, but there's our dove. Okay, so there's 1. 1, 2, 3. Bum bum. There and there. So there we have 3 so far. Come on. There we go. And then once we have the 3, we can then select all of them. Oh, copy. And then paste the next level here. So now we have, oh, it was 7, right? So we'll need to make them all a little bit smaller in order to make them fit. There we go. There we go. Here, here, and here. There we go. These are our counters. It's kind of fun. Creatures all in a row. All right, there we go. And then we'll copy this one and paste it. One more. There we go. So we have 7 doves in a row. And I'm going to make them all smaller. There we go, like that. So there are the 7 doves. And then, once I have the 7 doves here, I then copy and I paste here like that. And I paste again. And we do 6 rows total. There we go. 1, 2, 3, 4, 5, and then one more. There we go. Okay, so there are, and let's go ahead and move this down just a little bit more. There we go, like that. So there are the 6 rows of 7 doves, 6 rows of 7. And if we lay that out, we can then see that that is indeed the case. Here, we would have, let's go ahead and lay it out in this order. We have 1, 2, 3, 4, 5, 6, and 7, right? And then if we go over on, let's zoom out here just a little bit so we have the whole thing in line. And then we have, over on this side, we would have 1, 2, 3, 4, 5, and 6, like that, okay? Hopefully you guys can see that. I might have to grab the doves and move them over slightly. Let's see. There we go. Yeah, let's put them here. Boom, like so. And then we can put the letters here like that. Very nice. All right, so there we go. Then, of course, I have to move the top over as well. Oy. So we're dealing with columns. There. Okay, so there is our grouping. Okay. I wonder what that looks like full screen. Just take a look here at the... Oh, they're just backwards. Okay. Inverted image, an inverted image. Okay. They look much better in the regular in the regular black and white, but as I've said before, the image is inverted. So anyway, so yeah, there we go. So there are 42, and then what does it say in the, if I minimize this, it says place 7 counters in a line, which we did, and repeat that line in all 6 times, which we did. The number of counters in the whole is 6 times 7. The number of counters in the whole is 6 times, right? 6 times 7, right? Or 6 sevens, right? 6 sevens. If I reckon the rows from the top to the bottom, but if I count the rows that stand side by side, I find 7 of them, right? And 6 in each row. So essentially what he's saying, if we decided to make our groups here, right? If we decided to group the columns, and then we looked at how many columns of, or it would be how many rows, no, how many columns, right, of 6 elements there were, right? How many? So you go 1, 2, 3, 4, 5, 6, and you count that 7 times. That then would also give you, as he says, the rest of the information. But I need to copy it. So what had we gotten to? Go back down here. We had gotten to repeat that. Repeat that line in all 6 times. Repeat that all 6 times. The number of counters in the whole, so we did that, and now we go ahead and start working. The number of counters in the whole is 6 times 7. The number of counters in the whole is 6 times 7, is 6 times 7, comma, or 6 sevens, or 6 sevens. If I reckon the rows from the top to the bottom, and then reckon is, I think it's that, R-E-K-N. Yep. If I reckon, the rows from the top to the bottom, if I reckon the rows from the top to the bottom, from the top to the bottom. Yep, there we go. Semicolon. But if I count the rows that stand side by side, but if I count the rows that stand side by side, side by side. Is side by side a let me check and see if side by side is a brief form or a prefixal form. Side by side is not, although it would make a really nice one. Side by side, right? Let's go ahead and add that to the dictionary. Okay, so side by side would be side by. Yeah, so let's try that. We're going to do, we have side by side. All right. If I count the rows that stand side by side, comma, I find 7 of them. I find 7 of them, comma, and 6 in each row. And 6 in each row, comma, the whole number of which is 7 times 6. The whole number of which is 7 times 6 is 7 times 6, comma, or 7 sixes, or 7 sixes, period. And the whole number is 42. And the whole number is 42, comma, whichever way I count. And I think whichever is this, right? Let's check that. Whichever. Yep, whichever. Whichever way I count. The same method may be applied to any other two numbers. The same method may be applied applied to any other, the same method may be applied to any other numbers, to any other numbers, period. The sign of 23, or if the signs of paragraph 23, if the signs of section number 23 were used, comma, it would be said, it would be, and it would be said that 7 times 6 is equal to 6 times 7. All right, I will be back shortly. Okay, so we're back at it. Let's go ahead and continue. So it would be said that 7 times 6 is equal to 6 times 7. Okay, so let's go ahead and zoom down the page a little bit. And I think, go ahead and check, but I think that's the end of a section. So therefore, we need to go back over and reread 51. Okay, so let's go over the previous paragraph, which is here, 51. All right, 51. You may find in this way either 6 times 7 or 7 times 6, and for both you find 42. That is, 6 sevens is the same number as 7 sixes. The maybe this may be shown. So I need to change this to this. This may be, and then when I need to check shown. Yeah, the in needs to be a little smaller. There we go. Okay, line that up there. Continue. This may be shown as follows. Place 7 counters in a line and repeat that line in all 6 times. So we did that over here on the left-hand side, as you can see in the image that we have. Let's make sure we can see this. Yep, there we go. Good. So here we have 7, right? 7 columns and 6 rows to give us a total of 42. All right? The number of counters in the whole is 6 times 7, or 6 sevens. If I reckon the rows from the top to the bottom, if I reckon the rows from the top to the bottom, but if I count the rows that stand side by side, I find 7 of them and 6 in each row. The whole number of which is 7 times 6, or 7 sixes, and the whole number is 42, whichever way I count. The same method may be applied to any other numbers if their signs are according to, and then that's the end of the paragraph. If the signs of section 23 were used, it would be said that 7, the sign of multiplication, times 6 is equal to 6 times 7. All right, so moving on to 52. To take any quantity a number of times, so this is paragraph 52. to take any quantity a number of times, comma, it will be enough to take every one of its parts. It will be, and that can be a phrase, right? It will be enough, and enough is, it will be enough to take every one of its parts the same number of times. Of its parts the same number of times. Thus, a sack of corn a little bit sharper of an O hook. Okay. Will be increased 50-fold. Will be increased 50-fold. 50 fold. Let's see if that's fold. Yep, just a little bit longer of an L stroke. If each bushel which it contains, if each bushel, that should be bushel, check each first. Ah, curves the other way. If each, and then bushel, check bushel. Oh, it's just BSH, BSH. Which it contains be replaced if each bushel which it contains be replaced by 50 bushels. Be replaced by 50 bushels. A country will be doubled by doubling every acre of land. And then country, what is country? Oh, KT, yep. A country will be doubled. Yes, it is. It's just the two together. A country will be doubled by doubling every acre of land, every acre of land, or every country which it contains, or every country which it contains. Simple as this may appear, simple as this may appear, comma, it is necessary to state, it is necessary to state it, comma, because it is one of the principles, because it is one of the principles on which the rule of multiplication depends, on which the rule of multiplication depends. Period. That's the end of that paragraph, so let's go back and read through. Okay, here we go. Paragraph 52. To take any quantity. So that should be, there we go. To take any quantity a number of times, it will be enough to take every one of its parts the same number of times. Thus, a sack of corn will be increased 50-fold if each bushel which it contains be replaced by 50 bushels. Country will be doubled by doubling every acre of land, or every country which it contains, or every, it should be county, right? Or every county, that's what, or every county. Yep, so you just take country and then just add an E to it, or every county. Which it contains. Simple as this may appear, check up here. Simple as this may appear, it is necessary to state it because it is one of the principles on which the rule of multiplication depends. Okay, so now we go on to 53. Here's 53. In order to multiply by any number, in order to multiply by any number, you may multiply separately by any parts into which you may multiply separately. What is separately? Is it SPR, and then do you do it disjointed L, or is it a circle? Oh, it's just an E added. Okay. You may multiply separately by any parts into which you choose. Let me check choose. Yep. You choose to divide that number and add the results. And add the results. For example, 4 and 2 make 6. To multiply 7 by 6, to multiply 7 by 6, first multiply 7 by 4, and then by 2, and add the products. Oh. Oh yeah, of course. Wow. Okay, for example, 4 and 2 make 6. To multiply 7 by 6, first multiply 7. Okay, all right. To multiply 7 by 6. To multiply 7 by 6, first multiply 7 by 4, then by 2, and add the product. This will give 42. This will give 42. which is the product of 7 and 6. Line below. Elements of Arithmetic. And this is section 3. Page 4. This will give 42, which is the product of 7 and 6. Again, since 57 is made up of 32 and 25, 57 is made up of 32 and 25. 57 times 50 is made up of 32. 57 times 50 is made up of 32 times 50 and 50 times is made up of 32 times 50 and what am I looking at? Since 57 is made up of 32 and 25, 57 times 50 is made up of 32 times 50 and 32 times 50 and 25 times 50, comma, and so on. Period. If the signs were used, comma, these would be written thus. These would be written thus. Seven times 6 is equal to 7 times 4 plus 7 times 2. Okay? And then the next one, 52, or 50, times 57 is equal to 50 times 32 plus 50 times 25. So I need to make it a little bit more, a little smaller. $50 times 57 is equal to 50 times 32 plus 50 times 25. Okay. All right, moving down. Check back over this. This is 53 is what we're going through. Let's begin. In order to multiply by any number, you may multiply separately by any parts into which you choose to divide that. I need to check divide. Divide does require the D. To divide that number. And, comma, and add the results. For example, 4 and 2 make 6. To multiply 7 by 6, first multiply 7 by 4, then by 2, and add the products. This will give 42, which is the product of 7 and 6. Again, since 57 is made up of 32 and 25, 57 times 50 is made up of 32 times 50 and 25 times 50, and so on. If the sign were used if the signs were used, these would be written thus. 7 times 6 is equal to 7 times 4 plus 7 times 2, and 50 times 57 would be equal to 50 times 32 plus 50 times 25. Okay, all right, so now we just keep on going on. About 40 minutes left. Here is and then this is the takeaway. So this is going to be our law. This is the distributive law, a continuation taken from earlier. Here's 54. Highlight. And now we drop this, so this is 54. The principle in the last two articles. The principle in the last two articles may be expressed what is it expressed? May be expressed thus, colon, if A be made up of the parts x, y, and z, if A be made up of the parts x, y, and z, and z, MA is made up of mx, my, and mz, is made up of mx, my, and mz. Or if, and then we'll lay it out this way, or, and then if, is here we have A is equal to x plus y plus z, then A is equal to x plus y plus z. Okay. Or another way of writing it using the distributive law would be m of x plus y plus z is all equal to mx plus my plus mz. Okay. A similar result may be obtained if A, so we go a similar and I think that's similar, right? Let's check it. Yeah. A similar result may be obtained, obtained OBTN may be obtained, oh, add the tail on it, may be obtained if A, comma, instead of being made up of, instead of being made up of x, y, and z of x, y, and z is made up of combined additions is made up of combined okay. Is made up of combined additions and subtractions. Such as z plus y minus, no, is it z plus y minus z? That could be an x. That looks like an x, yeah. X plus y minus z, x minus y plus z, x minus y minus z, x minus y minus z, etc. To take the first as an instance, to take the first as an instance, isn't that just ins, right? For instance. Yes. To take the first as an instance, semicolon. Let a, here we go, so here's let, which I think you have to do let as in letter. No, just le. There we go. A equal x plus y minus z. A equal x plus y minus z. Then, so on the next line, we have then m a is equal to mx plus my minus mz. There we go. If, or for, and then here's our next line down. For if a had been x plus y. For if a had been x plus y, if a had been x plus y, ma would have been mx plus my. But since a is less than x plus y, but since a is less than x plus y, by z, by z, too much by z has been repeated every time. Okay, so less than by z, too much of z, too much of z has been repeated every time that x plus y has been repeated. Semicolon. And then hyphen. That is mz. That is mz too much has been taken. Semicolon. Consequently, let me check consequently. There we go. That's consequently. Consequently, comma, MA is not MX plus MY. MA is not MX plus MY, but MX plus MY minus MZ. But MX plus MY minus MZ, period. Similar reasoning may be applied. Similar reasoning may be applied to other cases, can flip back around. There we go. Comma. And the following results may be obtained. And the following results may be obtained to then build out the form. M A plus B plus C, A plus B plus C minus D. Let's go ahead and move this whole affair over. M times A plus B plus C minus D is equal to the distribution of M A plus M B plus M C minus M D, like so. Okay? And then we have some tables below with some various examples, which I'm not going to demonstrate, but you can see that all of those examples would be the same thing, which is namely the distributive law. This is the law of distribution. Okay? In fact, if we look that up here, that's in mathematics, yeah. An equation. Multiplying a number by a sum gives the same results as multiplying each addend separately and then adding them together. Yep. So that is called the sum. That's called the distributive law. That is called the distributive law. So if we go over here, let's go ahead and give this the name of distributive law. We go ahead and check in the dictionary to see if distributive is in there. There's distributive, and it's three forms put together. Okay, so let's just go ahead and rewrite it. So we're going to have the form here. This is called the distributive law. Distributive law. Distribute, and then tive law. All right, there's our distributive law, and it states that if you have a x plus y, like so, this is going to be the same value as, just make sure I'm adding it, that I'm looking at this correctly. A times x plus y is the same as ax plus a y. There we go. So you see, that is the distributive law. The distributive law. Okay? That should go on a t-shirt, you know? That'd be neat. That would be neat to combine those two. Gregg and mathematics t-shirts. It's a cool idea. I think I'll give it a try sometime. Okay, so let me go ahead and grab the PDF again. All right. And zoom down. Now we're at 55. 55. Paragraph 55. All right. But before I do that, I need to go ahead and reread 54. Okay. Let's go back up. Reread 54. Find our paragraph marker. There it is. We begin. Paragraph 54. The principle in the last two articles may be expressed thus. If A be made up of the parts x, y, and z, MA is made up of MX, MY, and MZ. Or if A is equal to x plus y plus z, MA is equal to MX plus MY plus MZ. M times x plus y plus z would then be equal to mx plus my plus mz. There's our law of distribution. A similar result may be obtained if A, instead of being made up of x, y, and z, is made up of combined addition and subtraction, such as x plus y minus z, x minus y plus z, or x minus y minus z, etc. To take the first as an instance, let, or is that let? take a look at it. Yes, it's let a be equal to x plus y minus z. Then mx is equal to, ma is equal to mx plus my minus mz. For if a had been x plus y, ma would have been mx plus my. But since a is less than x plus y, but by z, too much of z, there we go, too much of z has been repeated every time that x plus y has been repeated. That is mz, too much. Mz, too much, the multitude or the factor of m has been taken. Consequently, ma is not mx plus my, but mx plus my minus mz. So once again, you have to remove that amount, mz, by the amount. Similarly, similar reasoning may be applied to other, what is that? Similar reasoning may be applied to other cases, and is, and the following results may be obtained, which would be m times a plus b plus c plus d is equal to ma plus mb plus mc minus md. And then this gives the distributive law here. The distributive law of a times x plus y is equal to ax plus y. All right. I almost said measure. Paragraph 55. There is another way in which two numbers may be multiplied together. There is another way in which two numbers may be multiplied together, period. Since 8 is 4 times 2, since 8 is 4 times 2, 7 times 8, 7 times 8 may be made by multiplying 7 and 4 and then multiplying that product by 2. Multiplying that product by 2. Let me go ahead and add the page below. This is page number 5. Elements of Arithmetic, section 3. Paragraph, or page 5. Going back up here, previous paragraph, multiply, fix that up here. There we go. Since 8 is 4 times 2, multiplying 7 and 4, and then multiplying that product by underline product by 2. To show this, place 7 counters in a line. Place 7 counters in a line, comma, and repeat that line in all 8 times. And repeat that line in all 8 times, as in figures 1 and 2, as in figures 1 and 2. Okay, so what we're going to do is we're going to lay that out in the same way, figures 1 and 2. So he has 2 groupings here, 7 counters in a line, and repeat that line in all 8 times. 1, 2, 3, 4. Interesting, so he has them boxed. Okay. Well, what we'll do is we will make ourselves some counters, shall we? So I'm going to go over here, and I'm going to go to pictures, and we already did the dove, so now let's go ahead and do, let's do this little guy. There we go. Okay. All right, so there's our little guy. Well, that's a ram. We'll have him count as one of our, undo, as one of our counters. We're going to need him small enough. Cancel. Make him small enough. There we go, like so. And zoom in to the page. Need him to be just a little bit bigger. There we go. Put him here, and we need 7 of those. Okay. There's one. Then put our next one here. And then once we have this guy, we then select them both. Copy, paste. Now we have 4. Then copy all 4. And paste. Now we have 8. So now I can go ahead and get rid of 1. Delete. And now we have these group. That's a group of 7. And we need to do this 8 times. Starting to look like the flocks of the people of Israel. So we have, there's 3, and then there's, come on. Oh, there we go. There we go. Just took a little bit of time. Okay, so there's our first group, and then we're going to copy this and paste down below. So you see we have 2 groupings here and here. So that would be 7 by 4 and 7 by 4, okay? 7 by 4, 7 by 4. This is 4 by 7, 4 by 7. Okay? And then, notice all we have to do is, is that cleared out? Yeah, there we go. All we have to do is we have to rearrange the numbers, right? 8 times 7 or 56, but they're simply showing the different groups. Enclose each 4 rows in oblong figures as in A and B. And then the number in each oblong is 8 is 4 times 7 or 28. So what we're going to do is we're going to follow this same, we're going to follow suit, but what we're going to do is we are going to enclose them in different color boxes, okay? So let me go ahead and zoom in to Zernal, because the idea of grouping is really quite important. So what I'm going to do is I'm going to actually put these closer together, and we're going to show groupings a little bit, yeah, up here and up here. Going to grab our grouping here, move it close. Oh, undo. Can't I just grab? There we go. So I've got my grouping here, and what I'm going to do is I'm going to grab boxes over here, and we're going to draw a rectangle, and I'm going to change the color. I'm going to make the color red for the groupings of 4, okay? So, undo. Is it going to let me draw a box? There we go. So there is our grouping of 4. There's our 1 oblong, and then there's our 2 oblongs, okay? And then, so that's the 2 groupings, and that would be figure 1. And now what I'm going to do is I'm going to change the color, and let's do a nice shade of, let's do, how about, for me, well, for you yeah, so for you it looks kind of green. For me it's red because it's inverted. So now I'm going to do a shade of red for the small ones, okay? For the small groups. Here's 1 group. Here is 2 groups. Here would be 3 groups. And then we finally have our 4th group. Okay, so there are the groupings, and they're kind of stacked up on each other. Ooh, that's a nice shade. Kind of a purpley. Yeah, so purple. So the teal colored box is the first grouping, right? The group of 7 by 4, and then the purple colored box is the 2 by 7s. Okay, so that's what we're going to use as reference down below. So we'll go here, and we'll continue. So that's all of our groupings. And then we have the number of counters in all is 8 times 7, or 56. Let's change back to our black pencil. There we go. And I don't need this on. I just need letters, right? There we go. So we have the number of counters in all is 8 times 7, or 56. The number of counters in all is 8 times 7, or 56. Okay. But, as in figure 1, but, and then in parentheses, as in figure 1, as in figure 1, move this page down, and what we're going to do is we're going to label this as figure 1 over here. Let's do it this way. Let's use the colors that we just had. Select color, and we just had red, or sorry, for you that's teal. So if we go back up here, I'm going to call this one is going to be figure 1, okay? And I need to do it backwards for you. My apologies. Figure 1. All right. And hopefully you can see that. Hopefully it's clear. Looks like it. And now what we'll do is I'm going to switch over to that purple color. And once we have the purple, then I'm going to draw that as figure 4. Or, sorry, figure 2. So this is figure 2. Okay? And that's this one, and this one is also figure 2. Okay? Oh, come on, undo. There we go. There we go. Figure 2. All right? There we go. So we have figure 1 and figure 2. Okay, so let's go back down. So now we know that's what we're talking about. Let me zoom in. It doesn't like all those counters, I can tell. It takes longer to save. More images on the page. Okay, so there we go, as in figure 1. Switch back over to black. And now, as in figure 1. Enclose each 4 rows in oblong figures as in A and B. So we already did that. Enclose each 4 rows in oblong figures. Oblong, that's an interesting word. Let's go check that one out. Oblong, so it's just OBL. In oblong figures, such and such. Does it go backwards or is it? I'm forgetting this one. Let's check it out. Such as in A and B. So let's check such. It does. Good, good, good. Okay, so there's S. Such as A and B. A and B. Okay, so let's take a look. A and B. So let's do that. Let's rename them. This is A and B. Right? So let's do this. We'll call this one B. And we'll call this one A. All right? A and B. Okay. The number in each oblong is 4 times 7. The number in each oblong is 4 times 7 in each. Oh, what's going on? Yeah. Come on, there we go. In each oblong is 4 times 7. 4 times 7 or 28, comma, and there are 2 of these oblongs, and there are 2 of these oblongs. Semicolon, so that in the whole, in the whole, the number of counters is twice 28, is twice 28, or 28 times 2, or 28 times 2. And with that, yeah, I think I'm just going to finish, or I'm going to stop there for right now. So I'm going to go grab my lunch, about a 40-minute break. Yeah, about a 40-minute break, and then I will be back, and we'll get started in with the rest of this. I will be able to do, it's 1 o'clock now, when I can do 2, probably 3 hours. So 2, 3, yeah. So I'll be able to do another 3-hour session after I get back from lunch. So thank you very much for joining in. Pretty good progress on this one. We just keep on plugging away. So thank you very much, and hope everyone's having a wonderful day. See you in a bit.